Well, look at these A1C self-checking machines. These come with two tests and essentially disposable machines. I've opened one up a long while ago, and um, it was interesting, quite interesting actually. I'm going to open back up this one too, simply because I went and interfered with the actual chip inside here, and I damaged it, and it cannot be actually, well, it can't really be fixed. So if I can get a better picture on the microscope of this one, I'll go for it. So first thing, set of test pins, BGA package, not bad, pretty small traces and contacts. Again, medical device, so as you would expect, pretty well done. Right. The zebra cable, little zebra rubber to join onto the front here for the screen. So haven't been a long while since I saw one of those, but yeah, I guess it's one cheap way of doing it. Two contacts coming down. Those are the two battery positions. So that side will be the negative, and that will be on the board, and positive coming back, feedback into the system. Interesting, this whole thing has a lot of let me take this out right, wave guides to it. If you look at this, you can see there's a bit of fairly reflective plastic there, well defined optical grade stuff for optical operation. This is clearly an optical approach, and it's within a house in here that keeps it specifically where it needs to be. We'll look very carefully at that under the microscope, that one, this one. There are three chips, right? And there's the next one there. So there's four things going on here, and that corresponds to these. If we look, 1 2 3, 1 2 3, and that's the actual processor that comes off from there, and it comes off these, if you notice the traces. But oddly enough, that is not actually well, potted. You know, if you rub something against it, you damage your traces. And it had some dust when I was trying to take the microscope pictures many months ago, and I damaged the traces in that one. So what I'm going to do is pop this one open and see if I can get some better pictures of that. Apart from that, there's not much else that I could figure out on this. It's some optical method. Essentially, you plug the strip in. There's a little procedure, and you could check online and see what the procedure is on that. There's a little procedure to do this. You wait a certain amount, and you put a different thing, and you plug the sample in here, and there's two tabs that goes, and essentially, I believe these are two optical CMOS or some type of sensor like that, and determines an optical change that would occur based upon a chemical reaction, and that does the initial processing. I have no idea actually even from here I can see where I damaged those wires. Probably the initial processing, then this BGA package does pretty much everything else, and the display. So let me pop this one open, get some pictures of that. As I pop this open, you can recognize here this number, and this writing here is different on this one. So different version, different time of manufacture for sure. Nothing else looks different, but at least somebody revised something along the way. These are some close-up shots of the three ICs that were previously described on the board, and not much could be seen. They look black. You could see differences between them, but not much else could be picked up. Then there is the central chip on the back there that was not potted. Again, amazing. Broader view, and then a little zoomed in view where you could see the different sections in the silicon. It's amazing that it's a clear housing, and you could see all the little modules and different sections. Not that I could tell what they are, but it still is better than any decapping that I've ever done before, and this came, pre-open like that. You could see all the little contacts, the gold contacts, and how the wires come out. Interesting to look at. Just amazing that they left it like that.